Continuation of reviewing for the AP Statistics exam on how to find the equation of a least squares regression line. On the previous video, we went through the long and harder process of putting the data in the calculator, making the scatter plot, finding the equation, etc., etc. Here, we go over the easier part. How to find the equation of the least squares regression line from a computer output. So, sometimes a problem is presented where we get one of these computer outputs instead of the actual data. So let's look at this problem. A fisheries biologist studying whitefish in a Canadian lake collected data on the length in centimeters and the egg production for 25 female fish. Scatter plot and computer regression analysis of the egg versus fish length are given below. Note that the number of eggs is given in thousands. 40 actually means 40,000. Okay, that's important. Okay, could you describe, if I asked you to describe again, could you do sofa? I'll trust that you could say there seems to be a strong positive linear correlation between a fish's length and the number of eggs it produces in thousands. There don't seem to be any unusual outliers. Okay, how to find the equation of the least squares regression line. So you may remember when we were in chapter 3 that I said the column that's labeled coefficient was the only important column back when we were in chapter 3, and there's r squared. So if you ever needed r, you just take the square root of 0.697 and you'll get the value of r. So we'll see if we need that. Okay, now, when you see that coefficient column, one of those numbers is the slope and the other is the y-intercept. The row that is referred to as the constant will tell you the y-intercept, and the other row will tell you the slope. So, it's just given to us. So I can say something like this: eggs hat equals negative 142.74 plus 39.25 times length. And that would be the least squares regression line. Okay, oops, put that in the wrong place. Okay. Now, could you interpret the slope in context? Well, be careful here. 39.25 over 1 is not for every extra 1 centimeter of length you get 39.25 more eggs. Nope. For every 1 extra centimeter of length, it is estimated that 39,250 more eggs are produced on average. So be careful with that. The y-intercept is stupid. It's saying that when the fish length is 0, you get negative 142,000 eggs. Interpret the correlation coefficient. Oh, we needed r. So r equals the square root of 0.697. And if I grab my calculator real quick and see what I get 0.83. So would you say that there's a strong positive linear correlation between length and number of eggs produced? Be contextual, write complete sentences. R squared was 0.697, so we would say approximately 69.7% of the variation in the number of eggs produced can be attributed to the linear relationship with the length of the fish. So All of that part is the same as the previous video. Okay, now, finally, one more way to find the equation of least squares regression line. But usually you don't see this, but just in case, just as sure as I didn't review it, they'd put it on the exam. This is the most typical approach to a regression problem on the AP exam, is when they give you the computer output. So really try to be ready with that. Sometimes even a residual plot is given. And now that you know what a residual plot is and how it works, you'll know what to do if it's given. Okay, the third thing that I taught you way back when in chapter 3 is how to find the equation of a least squares regression line by hand if you're given nothing more than summary statistics. So notice that I'm only given x bar, y bar, the standard deviation for x, the standard deviation for the y list, and r. So I didn't even make contextual values out of this. I just wanted to go through the process. Okay, so we're looking for the equation of the least squares regression line y hat equals a plus bx. B equals the slope, and the slope is found by multiplying r times the standard deviation of y over the standard deviation of x. And by the way, this formula is on the official formula sheet. So B equals 0.82 times 17 over 12. So let's see, 0.82 times 17 divided by 12 is 1.16-ish. Okay, so now I know that 1.16 is going to go there. But we still need to find the value of a. Okay, so we found the slope. So now, here's what you do. You take y hat equals a plus 1.16x, because you know the slope now. And then what you do is you substitute y bar for y hat and x bar for x. So if we do that, we now have 33 equals a plus 1.16 times x bar is 28. And now all we have to do is solve for a. So we would have 33 equals a plus, well, I need to do this, 1.16 times 28 is 32.48. And then, of course, subtracting 33 minus 32.48 is 0.52. So there you have it. We now know that y hat equals 0.52 plus 1.16x is the equation of the least squares regression line that we found ourselves. I could ask you to interpret the slope, interpret the y-intercept, interpret r and r squared, just the same as I had asked you on the previous examples.